Okay, we're going to start with section 1.1 and then move to 2.1 in just a minute, but it's going to be the distance formula right here. So the distance between point 1 and point 2, where point 1 is just simply the x1, y1, and point 2 is denoted with x2, y2 in the formula. Okay, so then you basically take the second x coordinate, subtract the first x coordinate, take that answer and square it. The second y coordinate minus the first y coordinate, subtract that and square it, and then add it. And lastly, take the square root. So on this next page, we're going to do an example of that. And we're going to start with, let's do the ordered pairs when point 1 is going to be the ordered pair 2, negative 4. And point 2 is given to us, and it's going to be the ordered pair negative 1, 3. So I want you to write your distance formula down first, and always do that because you'll need to memorize your distance formula for the test. So write your formula down first and then plug it in and try to solve this. Okay, so we wrote our distance formula down and we plugged in. This is going to be x2 minus x1 plus y2 minus and then y1. But what happens when you have minus and negative there? Good, it becomes plus. So let's simplify that. Okay, don't forget these squares up here. And then we plug in negative 3 squared, and then this simplifies to 3 plus 4, which is 7 squared. And we just continue to simplify this. A negative 3 squared means negative 3 times negative 3, which is positive 9. 7 times 7 is 49. When we add that together, we would get the square root of 58, which in this case is approximately 7.62. Now, if my math lab asks for an exact answer, you'll probably give the square root, but ask for an approximate answer, it's looking for the decimal. Okay, this is our second example. I'd like you to try to work this one on your own, and then I'm going to work the solution and just show you your answer. So pause it and attempt to work this one. Okay, so when we plug our points in and we simplify right here, remember this is minus and negative, so 3 plus 5 is 8. 8 squared is 64. This is negative 4. Negative 4 squared is 16. We get the square root of 80. Now that isn't exact answer, but I'm going to show you some work in a minute about how to simplify that radical. And then the approximate value when you put it in the calculator is 8.94. So this is an exact and approximate. But this radical can be simplified a little further. You can do this in more than one way. I'm just going to give you a method to use. So basically, we're going to start with our value and take a prime number out. The smallest prime number is 2. So if I divide this by 2, I get 40, and I can continue taking the prime number 2 out until I can't divide it out anymore. So with 20 left over, and then so 20 divides by 2 10 times, 10 divides by 2 5 times. So now we have our product of prime numbers. So basically it's going to be this. But square roots pairs get to be taken out. So if it's a pair, because the index is a known 2 for a radical, right? For a radical, the index is a known 2, so that's why I'm going to circle pairs. Okay, so one pair of 2's come out. A second pair of 2's come out. The 5 is not paired up, so it's stuck under the radical. Okay, and then we simplify. So 2 times 2 is 4 square root of 5. So square root of 80 is approximately the exact value in the simplified form is 4 square root of 5. These two are the exact same. Okay, which that makes sense, right? What's 2 times 2? 4. What's the square root of 4? 2. So essentially, like, that's what we're doing, but it's just a very simplified method if you stick to that over there, because sometimes we could be working with cubed roots or fourth roots, and that tells you how many to group. So if it was a cubed root, we would have grouped groups of 3, and so on and so forth. So I kind of like this method just to give you something that's a basis that we'll be consistent with. Tons of ways to do it. I don't really care how you do it. This is just one particular way. So square root of 80, if the exact value would be this, approximate value is this. Okay, the next thing we're going to cover is our midpoint formula, which is given by this. Add the x values, divide by 2. This gives us our x coordinate. The y coordinate, you add the y values of the 2 points, divide by 2. And it's denoted by point 1 is given by this, and point 2 is represented that way. So we'll see this first example, and I'll ask you to find the midpoint of these 2 points. So if I give you point 1 and it's 4, negative 2, and point 2 is 2, negative 5. We're going to plug that into our midpoint formula and find that. So basically, visually, what that is point 1's here, point 2 is here. They're asking us what value is this? What's the midpoint? Okay, so that's kind of what we're doing there on a visual aspect right there. So I'm going to pause it while you plug this information in and work the next problem. Okay, so we plug all our values in, our x1, x2s, and then now we're going to simplify. 4 plus 2 is 6, and then what's 6 divided by 2? 3. Good. And then here, remember this is negative 2 plus a negative 5 or minus 5 would be negative 7 in the top, divide by 2, and we're just going to leave it in fraction form. Leave it in fraction form there, and we're done. So the midpoint is going to be the ordered pair 3 comma negative 7 halves. Okay, here's our next midpoint formula. There's all your given information. Now you will need to work on memorizing your midpoint formula, but pause it from here and work this problem and then check your answer. Okay, did you get negative 1, 3 as your midpoint? Okay, occasionally most of the other examples we were given an endpoint, they ask us to find the middle. They said, what's the midpoint? In this particular problem, they gave us our midpoint, so they told us this information, and they told us point 2, and they asked us to go back and find point 1. So we're going to set that up to work this kind of problem. So first start with your midpoint formula, write that down, and fill in any given information that we know. Okay, so we're looking for point 1, which is x1, y1. So when I plug information in, my midpoint, they told me was negative 1, 3. My x1, I don't know, I'm looking for it, and my y1, I just leave those values because we're going to find those. Plug in your x2, which is 3. Plug in your y2, which is 1. Now, what we need to do is we need to set this x value equal to this x value in the ordered pair and cross multiply and solve for the missing variable. Then the second thing we'll do is plug this in, set this equal to this side so we can find the missing variable to find our x1 and y1. So we're going to set that up and do that. Okay, so I set the yellows equal to each other here and the greens equal to each other here. Now we're going to cross multiply right here, and this is like over 1 if you want to have that there. So 2 times negative 1 is negative 2, and then 1 times x1 plus 3 just gives us that. If we solve for x1, we want to get it by itself, we would subtract 3 from both sides and find out that negative 5 is equal to x1. Okay, likewise on the other side, let me just put that over 1. Cross multiply here, 6. 1 times y plus 1 is just y plus 1. If we want to get y1 by itself, subtract 1 from both sides, and we get 5 is equal to y1. The ordered pair P1 ends up equaling negative 5, 5. So we can solve for missing points given midpoint as well.